we found this problem, so we definitely need to order one of these. Is there anything else we should be looking at while we're going around this board? Well, yeah, we still have this low resistance here, where this MOSFET was. That one. It's not quite as short. Let's have a look. I'm on ohms range. Yeah, it is 17 ohms, and that's from the gate to the source. So that could just be like a resistor. You know, sometimes you get a low value resistor between the gate and source. If there is, it's going to be in this area somewhere. Some resistors over here. Well, that's reading very low. That's reading very low. Oh, we've got another short on this, guys. Look, that's a capacitor. That shouldn't be short. This is okay. Ah, okay, so we know this is a switching regulator, like a buck converter. That's the coil. This is probably a flyback diode. That's short. That'd probably be the output diode from the coil. Looks like there's a short on the output. So there's two capacitors here, electrolytics. I think we can say one of them is the input capacitor, because this will run off the 24 volts, you would assume, or something like that, and the other one is the output. Let's have a look. So one of them is here, and that reads okay. The other one is here, and that reads short. Oh. So not only have we got this faulty chip here, and maybe because of this faulty chip here, we've got a short circuit on this voltage rail, look. We've got a short circuit on this voltage rail. That may actually be a capacitor, not a diode, thinking about it. So what is that powering? Well, the only thing I can think of is it's powering all this circuitry, because, well, this is a 74HC273, whatever. So this probably runs on a 5 volt supply rail, and the ground will be this pin, yeah, and the power will be this pin. And we have a short circuit. So this is a short circuit on the voltage supply that this is generating. If we look up the datasheet for that one, we should be able to work out what this voltage rail should be. Depending on the letters in this number, this is 74HC. It could just be a 5 volt supply, it could be something else. Let's have a look. Well, here is our chip, 74HC273, octal D-type flip-flop. 8 flip-flops, I said quad before. By the way, these are not the sort of flip-flops you wear to the beach, I will just mention, yeah. And also they're not the sort of flip-flops that you don't drive your car with here, because it's a €20 fine on the spot if you're caught driving the car with flip-flops on. Just one of the local laws. Makes a lot of sense, really. It's not very safe driving a car with flip-flops on. Makes more sense than the other law, which is that you get a €20 fine for driving a car without a shirt on, yeah. That one I've never understood, but it's true. Okay, so now we've waffled about that, and I've just looked through this data sheet. I don't actually see anywhere it mentions what the voltage is. Test conditions, it's saying voltage 2, 4.5 and 6, so I'm guessing between 2 and 6 is a supply voltage, and we can actually Google for that. Yeah, 74HC. Yeah, so it actually has a power between 2 and 6 volts. So it's very likely that this supply rail, well, it's definitely somewhere in between that. Depending on the other things being powered, it could be a 3.3. I doubt it's lower than that. It could be a 5, but we know basically what it is. So the question is, guys, where is the short? Well, I think we can say it's one side or the other of this coil. Yeah, this is the switching coil, the inductor. Which side is it? Well, if we get a data sheet for this and we have a look, we can find this. We've done this before using an ESR meter or a milliohm meter, micro-ohm meter sometimes. Let's try it. So we know there's a short here. Okay. Let's see which pin on this chip drives this coil. And while I'm at it, just one other thing I want to check. Is the effectively ground of this the same as the ground from this? You'd expect it to be. Yes, it is. So it's all referenced to here. Okay. Let's look at the data sheet for this one again. Okay, and here is the data sheet. So it's a 0.5 amp step down voltage regulator we looked at earlier, but in a little bit more detail. It says they're available in fixed output voltage 3.35. I was going to be one of these, or it's going to be the adjustable one. It's not going to be the 12 or 15. So maybe it is also marked. We can have a closer look at the chip again. And this is the pin out. So pin 7 is the output. Okay. This may be the diode that I could actually see that was by it, if it is a diode. And the short is from here to ground. We know that. So we need to have a look on either side of this coil really to see where the short is. Okay. This is the pin out. Pin 7 has a star. Yeah, there's two different packages. Ours is this 14 pin version. This says the output's on pin 12, not on 7. Oh, okay. Yeah, Luke. That is the output pin on the 8 pin version. Ours is on pin 12. So let's have a look and let's see now if we can determine which chip ours actually is the output voltage. Okay, here it is. Oh yeah, look, LM2574 5 volts. This is a 5 volt version. Maybe it was there before, I just didn't really look. This thing, well, it seems to be connected to the coil. I think this is probably that diode we could see, like the Zener diode type thing, most likely. Where's the short? Well, let's try the ESR meter because this is usually very good at finding this sort of short. Okay, so I have the ESR meter. I've put it onto manual range and I'm on the 100 ohms range. So if I short the two leads together, it will actually read 0, okay? So the way this works, this injects 100 kilohertz. Now, a capacitor to ground at 100 kilohertz is like a short, yeah? But an inductor is a resistance. It resists the AC. So if we measure from either side of this coil to ground, and one side will just be measuring whatever the capacitors are going to ground, which is probably 0. Let's have a look. Yeah, 0 or very close, okay? On the other side, we'll be measuring through the inductor to ground. So this should read quite a high resistance. Well, it goes to pin 12, which is here. And that reads open. I think actually that point goes to this point. Yeah, it does. So our coil is of such a high resistance, it actually reads more than 100 ohms to the ESR meter. So we can definitely say the short is on this side. We'll compare that with the multimeter and then the low resistance meter, okay? So on the multimeter, I'm actually on the 40 ohms range. I just short the leads together, hit the calibrate button. I'm now on the 40 ohms range. Let's have a look at what we've got, yeah? So again, from the output of the coil, which is here, to ground, it reads 0. Yeah, it reads 0, okay? And from the other side, which is pin 12 to ground, it reads 0.5. 0. So again, we're getting a slightly higher resistance here, which is the DC resistance of this coil. So again, that says the short is on the output side. Let's use the milliohm meter as a final check. Yeah, so milliohm meter, 200 milliohms range. Let's have it. Let's just zero it. Okay, that's zeroed. So again, output from the diode, which is output of the coil, 53.5 milliohms from pin 12, which is actually here. Well, it's more than 200 milliohms. Let's go up a range. It's actually about half an ohm. Yeah. And this output side is 0.05. So everything is telling us off the 3 meters that the short is on the output. And this is bad, guys, very bad, because this goes everywhere. We know it powers this chip, and it's probably powering this lot as well. The problem is you can't easily say, because there will be ground on these anyway. So you will find some pins here that actually connect here. Yeah. And you don't know if they're supposed to be ground or not. But what you can say is these capacitors shouldn't have shorts across them. And they buy these chips. So we can say by measuring across here and here, not that one, but that one, across quite a lot of these capacitors. So we can pretty much say that power rail goes to all of this lot. And something is short. And it could be a capacitor, it could be one of these chips, which is game over. It could be that one. The only easy way to find out probably now is going to be to inject 5 volts into here, or inject current into here with the power supply set to a maximum of 5. It won't give 5 because it's short. And see if something warms up. And I think I'll probably use a thermal camera actually. So let's get that set up. I think we'll have to solder a bit of wire onto here to easily do it. Yeah, we can do that. We can solder the wire on the output of this coil. We can clip onto ground. That's easy enough. And then let's see. First of all, with the fingers, is anything getting warm? And if not, with a thermal camera. Okay. You need to take a bit of care, by the way, when you're doing things like this, because you don't want to inject too much voltage. Now, you may have a board where there are other derived power supplies. So in other words, other buck regulators. You'd see the inductors, which may have like a 1 volt supply or a 1.5 or something for some of these chips, and they are derived from this one. And if that's the case, you don't want to supply any more voltage into here than those derived voltage supplies are, because the short could be through to one of those rails, okay? And if you put 5 volts in here, you're going to kill things, yeah, if they're not dead already. So in this case, there aren't any other derived voltage rails. There's no other buck regulators on here, so I'm perfectly happy that I could put 5 volts into here, and it will not cause problems further down the line to a lower voltage supply, because from what I can see, there aren't any. But having said that, because of the short, when I inject the voltage, the chances are there'll be almost no voltage coming in anyway. So let's solder our wire on. Now we've sorted that little issue out. We can solder it onto here. This is the output of the coil. And you can inject our current here. This is not a very thick bit of wire, but I don't think I'm going to have to get a huge amount of current into this. We can see. I think it's thick enough for what we want to do. It'll probably take a few amps, that will actually. So this is going to go to the positive output of the power supply, which you can see here, and then the negative we can just clip to this capacitor. Okay? And then let's see if something gets warm. And hope it isn't something like one of these chips, yeah. So this is the ground, black wire, straight onto our capacitor. Okay. I'll in fact switch it off again. This is our voltage supply. We'll turn the current down quite low and we'll power it up. Okay, and it's gone to 0 volts constant current. And we can now inject some current. So you see the voltage is about 0.1. And I'm going to put a couple of amps or so into this, and let's see if something's getting warm. That one might be getting a little bit warm. Okay, I don't feel anything getting warm, so let's get the thermal camera. Okay, here is our PCB. Let's switch the power on again. So we're injecting a bit of voltage. Anything getting hot? Something there, maybe. So we get a focus on it. Okay. I think that's just where we're actually injecting the voltage. Anything else getting hot? No, I can't see anything. A little bit, maybe something at the top there. What's that? That's this thing. Oh, that's shiny. Shiny things will do that. Let's increase the power. Yeah, let's give it a bit more power. So about 4 amps. Now is anything getting hot? Nothing obvious again. So this is getting warm. This is where the coil is. Okay, but nothing else. The wire is getting a little bit warm. But oh, you can't feel the heat. It's just obviously because it's coming flowing through the wire. Anything else? No. I'll have to put some more power in. It's about 5 amps. Well, guys, the one thing that is getting hot is down here. This is where the what looks like a diode and the capacitor are. Let's see if we can focus on it. Particularly, I think the capacitor is getting hot next to the output capacitor. I can't feel any heat there. Let's put the temperature thing on, the little reticule. Okay. That thing is hot, guys. Can you see it? 55 degrees. That's our short. So the good news is the short appears to be this capacitor. Yeah, that's where it appears to be. So if we unsolder this one, we should be able to unsolder that one, and then let's have it to see if it actually is faulty. So I'll take the electrolytic off first. We can then test this, but I'm sure it was that one that was actually getting hot. Okay, that's the electrolytic capacitor. We can just check that one. It's here. I'm confident this is okay actually, but let's see. Yeah, that's okay. Short is still here. Across both of these, but that seems to be what was getting the hottest. Let's unsolder this. I think I'll come in from this side with the soldering iron. This should just come off. Add a bit of leaded solder first, both ends. You'll probably notice I'm using exactly the same soldering tip as I was using for the micro soldering, for drag soldering on the previous video, a couple of videos ago. Okay, so we can use it again. This is kind of like almost a universal, this BC3. I use it for practically everything. Okay, let's get hold of the capacitor, and this should unsolder. Hit one end and the other, back to the first end, and this get a bit of heat and should come off. Okay, there's obviously some heavy ground plane which is coming, yeah. There. I actually had managed to melt it about 3 times before I actually removed it. Okay. I'll just clean the board up. I think we can see now, I've cleaned that up, that in actual fact these are all effectively in parallel. The electrolytic, the other one, okay, not the diode that was reading through the coil, I think. So let's see if the short has gone. No, it is still there, so it wasn't that, but something here was getting hot. Let's take this one off as well. Let's make a note which way it actually goes. Stripe to this end. Okay, let's remove it. I'll just check the capacitor, by the way, but this should read okay. You would think this won't be short, but let's have a look. Yeah, capacitor's okay. I'll put it in a little anti-static bag so it doesn't get lost. Same technique, but it could be a bit tricky with it being bigger. You might have to use hot air, in which case we'll remove this capacitor first. We'll try. If it doesn't work, we could try using 2 soldering irons. I'll just heat this end, get plenty of heat in, then heat the other end and see if it'll come off. Okay, yeah, it's off, look. Okay, so that's off the board. There's the short still there. Yes, so although something seems to be getting hot down here, that isn't the short. So we'll have to inject some current again and see what else gets hot. That surprises me, guys. I'm sure you could see that was getting hot. Okay. This capacitor's on the input voltage, not that. Could go for that one while we're in this area. But let's try the camera again. Yeah, it looks like this diode thing actually might be what's getting hot. I mean, it's in the same area. Try and focus it. That's the transformer, that's cold. Oh, it looks like it's the diode, that one. Okay. So it's in the same area again, it's this component. Everything else has been removed. And if you look at the component, it does read short, so let's take that one off. There's nothing else around here, so I'm thinking this must be it. Maybe just the heat was all kind of like spreading around, and that's why I couldn't see the right one. Let's try it. The question, of course, is this is a diode. Is it a Zener diode or a normal diode? I'm thinking it's probably a Zener diode. If one end goes to ground when we've removed it, because obviously it looks like a short at the moment anyway. One end goes to ground and the other end goes to this positive voltage rail. This is this capacitor. That would suggest this is a Zener and somewhere just over 5 volts. Protection device, yeah? Let's have a look. I think we can see which end of it is which at least. Just turn it around a little bit, make it easier to pick up. Heat one end. Get the other end. Try the tweezers on it. A little bit awkward this one. We'll get it. Try this way. Again, I can use hot air. Ah, it's come off. It disappeared somewhere, but it came off. It kind of flirted out of the tweezers. Not sure where that's gone. Let's see if the short has gone. Okay. Put it onto continuity mode. Okay. Well, it now reads a resistance. We're now reading about 4 ohms on this. I'm guessing we're reading that across this chip as well. Let's have a think. So if this is a 5 volt rail and that's reading 4 ohms, this is just over an amp. Yeah. And if it's just over an amp, that ain't going to supply it because that's an half amp regulator. So it looks very, very much like what has happened here is that there's been some sort of surge. That's going to be a Zener diode. If we go from here, this will be going to ground. Okay, and the other end will read 4 ohms or something to ground. 4 ohms to ground. So that is where the positive end was. That's effectively across this capacitor. So this must be a Zener diode. Nothing else makes sense. And it's probably something like, say, a 6 volt Zener. So that if the volt, or 5.6, something like that. So if the voltage goes too high, it effectively goes short and protects everything else. But seriously, guys, I think there has been a surge that has gone short, but not before other things died. Yeah. Why else would we be seeing 4.4 ohms across there? 4.3. It's going to draw over an amp. I could put 5 volts in it. Well, it'll go to just over an amp and power this lot up, but unless we're lucky, there's another capacitor or something. Something may not even get hot, yeah. Something may not even get hot. We can try it. Okay. I've turned the current right down at the moment. So we have about 2 amps at 4 volts, yeah. What's getting hot? Well, actually the board seems to have powered up. Red LEDs come on. But this one is getting very hot. This one's not so bad. That one's getting quite hot as well. Looks like these two. But that was 3.5 volts coming in, and we know this supply can only provide half an amp. So I would say that this chip has gone and this chip has gone. What I think's happened here is that this chip, which is controlling the motor, had a short between power and out 1, yeah? And other pins on this are driven by this lot here, controlling it basically. And I think that 24 volt, which shorted to out, is somehow also in this chip got into the 5 volt, which provides power to this lot. Come back at it this way. This diode went short because of the high voltage, but not quick enough to save this lot. This one is definitely gone, and it looks like this one's gone as well. And I don't think we can replace that. Let's see what it is. I mean, this we could replace. Yeah, this we could replace. These are nice and cool. Obviously, the power rail was up, you could see. Although this wouldn't be able to provide that much power. So that would act as if it was dead. That's what they said. And I think this one's died. Let's see what it is. But I don't hold out much chance. So here's our chip. But this looks to me like it's going to be something like that's programmable. I wouldn't be surprised at all. and therefore we can't do anything with this. EPM 7032 Li44. Let's have a look. Okay, straight away, it's a complex programmable logic device, probably like a kind of a FPGA type thing. Yeah. So this is not anything we are going to be able to fix. Clearly we can't change this chip. The only thing we can try now, and this is a long shot really, but we may as well give it a go since we're here. It doesn't look like this chip connects to that one, not directly at least. But what we can do is remove this one and then see whether this resistance has gone up a lot. If it has, I mean, it's possible maybe this has got the short and it's causing that one to effectively draw more power and get hot, but if that's the case, it's also quite possibly damaged it. But we can try it. So to remove this, we're going to unsolder one end of this capacitor. I don't think we need to take it off, just unsolder this one end. We'll get this off the board, and then let's just see again. This is really the last chance saloon, yeah? This is stuck down with glue, just typical. Oh, but it came away, it's no problem. So let's unsolder this end. Okay, just heat it up and it should just come out quite easily. There we go. So we can move the capacitor far enough out of the way. I'll just get that stuff off the board. So we'll remove this one. I'm going to use the same technique I use with most things, which is to add leaded solder, get the hot air and hopefully just lift it off the board before any of the lead-free solder on the nearby components even melts. Okay. So flux. Yeah, we can see which end is pin 1 up here anyway. Hopefully it's marked. It probably isn't actually, but we know which one it is. Take a bit of leaded solder. And get it onto all the pins, possibly just bridging them. Okay, there's plenty on there anyway. And the same on this side. And this should melt before the lead-free does. I think I will come in at it this way. I can slide it that way. There's no components here that are going to come off the board. Although, because the lead-free solder won't melt, it probably wouldn't anyway. We'll just put this up onto a metal stand. People comment on this. No, it's not really a heat sink. It just stops me burning the bench and the mat. Let's take this off. Okay. I'll just clean the pads a little bit while I'm here. That's nice and warm. Right, let's see whether our short or low resistance as it is now is any better. So ohms range. And we're reading 23 ohms, so it's a lot higher. So I think it's worth putting the 5 volts back on this, and let's just see if this is still getting hot. You may have noticed my wife has popped out and she has my phone with her, so I can't connect the thermal camera, and I don't have the PC set up that it will work with. So let's just try with this first. If we can see this is getting hot, we know it still has a problem. If we can't see anything obvious, I'll have to wait till I get the thermal camera again. So I have the power supply set to 5 volts. Let's see what it does. Well, it's drawing 2.37 amps, yeah. And we know full well that this supply can only supply half an amp. That's hot. The temperature gun didn't seem to pick it up, but it's hot, yeah. This is all cooled down now from the desoldering. So this chip is definitely defective. The only thing we can really do now is to contact the manufacturer of this. They do have a website to see if a replacement is available, how much it will cost, and do we need to do any sort of configuration work to get it to work on their system. So I will be emailing them after the weekend and see what they say. As I said at the start and in the description to this video, to do this sort of work is really a combination of 4 things. First, you need a basic knowledge of electronics, what components do, how to test them with a multimeter or take them out and use a component analyzer, and also a basic understanding of circuit building blocks. This is a motor controller. These, although I don't know what they are, will be either little coils or opto-isolation to the outside world, the same as these. Yeah, this is a buck regulator, this is a voltage rail. So when you start to look at a PCB and see those circuit blocks, you can, as I did, okay, use the data sheet, you can work out what this is. So you know it has a 24 volt supply, you know this is driving the motor. You know that this is a buck regulator, and we can work out, as we did, 2 ways. One, looking up the voltage spec for this chip, and one, looking at the markings on that one, what that voltage rail will be. And then you can start to inject voltage. You know, you can see shorts. You know where there should be a low resistance, where there shouldn't. And that's that basic knowledge. And you can learn that. It takes some time, but you can learn that. The more you watch videos, the more you study, the more you will learn, okay? The second part is intuition. Really, this is a matter of following your nose. This is experience that will give you this. So as you've worked on more stuff, you remember what goes wrong with it, and you build up an idea in your mind of what is most likely the fault. For example, short circuits, probably power components, or these little capacitors. They are very prone to failing in that way. So that is the intuition, but really it's experience, okay? The third part is what I call the voodoo, the black magic. Now this, I can't teach you this, and nobody can teach you this, but you can learn it, okay? This is a way of thinking. This is being able to take all these voltage measurements and work out in your mind and hear what is going on. And then, as I do, you'll come to, and then you'll go down a certain branch, a train of thought, which may be the wrong one, but you will go down for a reason and you'll prove it's the wrong one. Then you'll come back and look again and you'll have another, and you'll go another way, and this may well be the right way. This was interesting because he's had 2 separate faults, but in the end, I think we can prove that this one fault caused the other one, and it's nice to be able to do that. So that's the voodoo, that's the black magic. And as I say, it's a way of thinking, it's a mindset, it's a methodical mindset. Some people seem better than others at doing this, I will say, and this is what kind of separates the men from the boys, yeah? But you guys can learn it. And when I say guys, by the way, I include the girls, okay? I just mentioned, so in Spanish, a group of guys is chicos, yeah? A group of girls is chicas. But if you get like a group of guys and girls together, they're chicos. And nobody complains, nobody thinks that's sexist. Yeah, I like the Spanish language. Anyway, I've witted on, yeah. Last bit is luck. There is an element of luck to this. If you just happen to be measuring the right place, you find the right thing, you may do it straight away, you may do it 45 minutes later, but if you stick at it, you will do it. But the luck comes in. In the end, we can't repair this, but we know why, and that's just bad luck. Yeah, so that's the luck. So put all those 4 things together, and anybody can learn to do this, but nobody can teach you some parts of it, okay? The last thing I will say, guys, this takes some patience. This takes attention. You have to concentrate on this. I know some of you guys skip these videos. If you really want to learn, not just my videos, if you want to learn, guys, watch them. Yeah, that's my lecturing to you now. If you're going to learn this, you need to have the patience and the attention span to sit through and watch this stuff, because if you don't, you'll never get there. If you want to skip to the end to see what was wrong with it, well, I'm afraid when this is in front of you and you're on your own, you ain't going to do that. Okay? So there's my little lecture. That must be 45 minutes now. And I'll see you also on another repair video. And if I find some more information about this from the manufacturer, I will post it in the comments below. Okay, guys, hope you enjoyed it. Ciao for now.